All right, Diane Liddington here, going to talk about my water filter that I made. So when I was planning things out, I decided to use, so I wrote everything out about all the layers, their properties, and what I decided to do um, was really look at the properties and mirror those. So the bottom cup was my bedrock where all the water, the filtered water collected. Above that represented the fragmented rock. I chose to use gravel because it is solid rock chunks, pieces, not as solid as bedrock, but it is broken up into relatively large chunks. The layer above that, that subsoil, is little tiny pieces, quite compact, kind of like clay. Still has some porosity to it, but it is pretty dense and little bits there. So I used the sand. Next two layers for my topsoil and my humus, because both of those layers are organic, I chose to use materials that are also organic. So I chose charcoal to put into that topsoil. Similar porosity, has that organic nature. And then I chose to use the wood shavings to represent the humus because of the porosity there, and that sort of weaving thing going on. And then I sprinkled in the alum in there so that I'd have that absorptive property to pull up those colloids, which is exactly what's going on in the topsoil with the charcoal. So here is our planning. My boys helped me a little bit here, putting in the push pins, and then, well, this was an experiment with how many holes in the cup would make water come out. But my column over here, there is the before picture. The after pictures. This on the left is the water that I started with, pouring into my filter. After I had poured it into the column, it started settling a little bit. Obviously, it wasn't all truly dissolved. It was just kind of floating in there. Some of it did settle out, so it's not quite as dark now. But here is that nice clear water that came through my filter. Because I am a proponent of quantitative data, I pulled out my handy dandy dissolved solids meter and measured my starting water. It was somewhere, when I measured it here and I measured it here, it was somewhere between 340 and 400 ppms. This water, I tested the clear water, it was like 900 parts per million. So clear water is not always clean water, and that becomes another fun extension conversation that you could have if you were to use this activity. To assess this activity on the science and engineering practices, it really is wonderful. It illustrates them so effectively. The students are so engaged in these practices. They're asking questions. They have to plan and carry out investigations. It is their baby that they're doing. They're coming up with their own explanations for things off the empirical evidence that they have. They're communicating about science, about the natural world. They have to pull information from all these different sources. Is it valid? Is it something that can be trusted? Is it a good source? Does it match with what we're seeing in our experiment? They're certainly arguing over what's the best avenue. What do I do? This is modeling at its best. The only two places where I didn't give it a 4 were in mathematics and computational thinking and analyzing, interpreting data. The data part depends on what you're collecting, whether it's quantitative, qualitative, what they're looking at. So they're definitely doing that. Are they going to graph it? Whatever, that kind of thing. So definitely proficient, level 3, nice. With the math, I circled in between the 2 and 3 because it depends on the angle and how you look at that activity, and if you truly do use any sort of mathematics in your modeling there. But that's kind of up to the direction that you give the students. Love this activity. Thank you.